So today we're going to go through fractions and turning them into decimals. First of all, let's see things that we already know. We know that 1 over 2 is equal to 0.5. And this is true because two 0.5s makes 1 and 2 halves make 1. So these are the same. Now what else do we know? We know 1 over 10 is equal to 0.1. And we know 1 over 100 is equal to 0.01. So knowing these two things, it helps us solve for things like this. 2 over 5. We will think of the numbers that make either 10 or 100. In this case, we can multiply the top and bottom by the same number so that we can get 4 over 10. And we know each tenth is 0.1, so 4 tenths is 0.4. Let's try this again. If I had 5 over 25, for instance, what can we multiply so we get 10 or 100? We can multiply by 4. And whatever you do to the bottom, you have to do to the top, so you don't change the question. So now we have 20 over 100. So 20 of these would mean 0.2, which is the same as 0.20. 20 of those. Okay, so that's one way to do it, but what's another way to do it so when we can't think of numbers that make 10 or 100? So we know the answer to this, but how can we work out the answer to something that looks like this? 3 over 8. We have to find another method. So let's figure out another method for this. 2 and 5. Now 5, we do long division. 5 into 2 goes 0. Put a dot. 5 into 20 goes 4 times. 4 times 5 is 20. Remainder 0. So we're done. So the answer is, as we expected, 0.4. So this method works. So we're going to use this for things that can't be multiplied and by numbers that to make it 10 or 100 or easy decimals as we did before. So let's try this one. So again, 3 over 8, we'll put the 3 over here and the 8 over here, and we say 8 into 3 goes 0 times, so we'll put a decimal point. And then we say 8 into 30 goes 3 times. 3 times 8 is 24. So now we have remainder 6. Bring another 0 down. 8 times what is 60? 8 times 7 is 56. 60 take away 56 is 4. Put another 0. There's an infinite amount of zeros. 8 times what is 40? That's 5. 8 times 5 is 40. Remainder 0. So now we can stop. So 3 over 8 is equal to 0.375. Can we use this method to do recurring decimals? Now pause here if you want to copy this. Let's do the next bit. Can we use this for recurring decimals? Well, we know 1 over 3 is equal to 0.3333. Let's have a look whether it works for that. So 3 into 1 goes 0. 3 into 10 goes 3 times. 3 times 3 is 9. Remainder 1. We put the next 0 down. 3 into 10 goes 3 times. 3 times 3 is 9. Take away. Remainder 1. Put another 0. 3 into 10 goes 3 times. 3 times 3 is 9. Take away is 1. And we can keep going and follow this pattern and realize that we will go on forever. So 1/3 is equal to 0. Oops, no space. Let me put it over here. 1/3 is equal to 0.3 recurring. So whether you're doing a terminating decimal or a recurring decimal, you can use the same method. You can use the same method. You have to use division if you don't want to use a calculator. Okay, let's see what happens if we have mixed fractions. So for mixed fractions, let's say, let's do something with these numbers in there. Let's say if we had 5 and 3/8. Now for mixed fraction, you would separate it and realize it's 5 and a bit. You don't have to do anything to the 5. And for the fraction, you would do exactly the same method as we did before. You would do the long division and you would get your answer. And therefore the mixed number becomes 5.375. So the only thing you really need to worry about is converting this fraction bit into this decimal bit. Let's try one more example. I'm going to rub this side off. Let's do 2 and any random number really we can do. 3/5, which is equal to 2 plus 3/5. So we have to figure out the 3/5 bit. So the 3/5, we know is 0.6. If you know it off by heart, that's fine. But if you didn't know off by heart, we can work it out. 5 into 3 goes 0. 5 into 30 goes 6 times. 6 times 5 is 30. Remainder 0. So we have 2 plus 0.6. So our answer is 2.6. And that's how you change mixed fractions into decimals. Thanks for watching. Don't forget to subscribe and then you can get notification next time another explanation pops up.